All right. So for exponential and logarithmic equations, we've been working with logs now for what, 2 lessons, I believe. We started with exponential, and then we went to logarithmic and stuff like that a little bit. So first off, what you have to do to solving an exponential equation by, I can't spell, there we go, exponential equation by, no, I'll just post it after the day, after I teach it again. Expressing each side has a power of the same base. Okay, so if I have b to the m equals b to the n, then m equals n. So if you have something like that, it's a little three-step process. One, you want to rewrite in the form b to the m equals b to the n. And then set m equal to n, and then just solve for a variable. All right there, Andy. All right, so let's look at an example. If I have something that looks like this, maybe. Two to the 3x minus 8 power is equal to 16. All right, can I rewrite 16 as something to a power and have a base of 2? So 2 to what power would be 16? To the 4th. Okay, so I can rewrite this as 2 to the 3x minus 8 equals 2 to the 4th. We agree? All right, so that was just using that rule, putting it in that form, b to the m equals b to the n. All right, so now I can essentially forget about the 2's. So now I can just have 3x minus 8 is equal to 4. Okay, so then I just add the 8 across, so I have 3x equals 12. Divide both sides, and x is going to be 4. All right, that one's not too bad, is it? Let's step her up just a little bit. Either one, but this could be m, and this could be n. Just your exponents. Okay? No, you will not have to specify which one is which. Why is it moving? All right, anyhow. So next one, let's go 27 to the x plus 3 power equals 9 to the x minus 1. Now, this one's a little trickier because I can't rewrite this on just one side, can I? All right, 9 to a power is never going to be 27, vice versa. But aren't 27 and 9 both have both are powers of 3, right? So sorry, I couldn't spit it out there. All right. So 27 is actually 3 to the third, correct? All right. So I can have 3 to the third to the x plus 3 power. Okay. So let's rewrite the other side. 9 would be 3 to the what power? It's a second. All right. So that's 3 squared to the x minus 1 power. Okay. So now we're very, very close. Okay, it's not quite in the bm equals bn because 3 to the third and 3 squared are not the same, right? But I can essentially take this out and have it ready to distribute. Okay, so 3 to the 3x plus 3 power and 3 to x minus 1 power. So now I officially have it in that form where I can essentially eliminate the base. Now this is equal to 3x plus 3 equals 2 x minus 1. Okay, so from there we'll distribute. So I got 3x plus 9 equals 2x minus 2. Subtract the 2x to the left side, so it's going to leave me with x. Subtract the 9 from the right side, and that's going to give me negative 11. Questions on those two? Anybody? All right. Let's go. I'm gonna put 2 up here. I want you guys to try them. First one, 5 to the 3x minus 6 equals 125. And we'll also go 8 to the x plus 2 equals 4 to the x minus 3. All right, try those two, please. Wait, 5 to the 3x minus 6 equals what? 5 to the third. Okay, now what? Okay, good. We applied the rule of the MN powers thing. Okay. Okay, plus 6, you get 9. And then do what? Divide by 3, so x is going to be 3. All right. Anna, why don't you walk me through the second one? Uh-huh. Uh-huh. Let me write this down real quick. Okay, so we distributed because that number would come outside, right? And we have to make sure we distribute to the whole exponent then. We would have the same base then whenever we bring that power to the outside. All right, so distribute it. You get what on the left side? Right side? Good. Okay, so I subtract the x over, and then subtract the 6 over, so x equals negative 12. Good. How many of you guys got that one? Good? All right. Good. I like it. All right, so let's use some logs now. So if we are going to use logs to solve exponential equations. All right, so here's your steps. First one, you want to isolate exponential expression. All right, two, you want to take common log of both sides. For base 10. And you would have the natural log for bases other than 10. I'm going to simplify using one of the properties. And then solve for the variable. I'm going to write two properties in there, so that's why I left space. All right, so we can use the properties of bx equals x ln of b, or ln of ex equals x, or log 10 to the x equals x. All right, so those are the properties that'll come back and show their head again as we're going through these. All right, so let's look at some examples here. So first one, let's go. What? Better? All right, so I got 40x equals 15. So what I can do, all right, this looks like the very first one, right? B the x. All right, I have that exponential on a side by itself, so I'm in good shape there. So I'm going to go ahead and apply this property right here, okay? So 40x, so I'm going to say then that I'm going to have, sorry, I wrote that wrong. Come on. What the heck? All right. So I'm going to apply the natural log to both sides. So I have the natural log of 4x equals the natural log of 15. Okay. So with that, then I can bring that x out front. So I have x natural log of 4 equals the natural log of 15. So now I'm solving for x. So I can just divide both sides by the natural log of 4 now, right? So let's divide both sides by that. So I have x is equal to the natural log of 15 over the natural log of 4. That makes no sense whatsoever there. Anyway, natural log 15 over the natural log of 4, all you have to do is plug in a calculator. All right, natural log of 15 divided by the natural log of 4, that's going to be about 1.95. And I think we should see that too, that it's saying 4 to what power equals 15. Well, 4 squared is going to be 16, so it would be a little bit under 2. All right. Now let's do one like this. So I have 10 to the x is 120,000. So 10 to the x equals 120,000. Now this guy has a base 10. So I don't want to apply the natural log to both sides. I want to apply the common log to both sides. All right, so I'm going to log both sides. I got the log of 10x is equal to the log of 120,000. Same thing as before, I can pull the x out front using that property. X log of 10 is equal to the log of 120,000. And then divide both sides by log 10. Okay, well log 10 is the same as what? It's equal to 1, yeah. All right, so I don't even need this, it's just equal to 1. So x is equal to the log of 120,000. The log of 120,000 is going to be approximately 5.08. And again, that's just punching that one in the calculator. All right, still good? All right. How far do I want to go here? Give me 1 second.